done a lot of it, but the mic should pick up pretty well. Okay, there you go. You're on. And we're shared. Okay.
Okay, we're gonna get started. Your work is set. Go. So my name is Curtis Carroll. I'm with Adobe. I've been with Nick and Pat for on a couple of event type things, and they've kind of drugged me into this, which is good because it's going to help me. So I appreciate that, Pat. Wherever Nick went, where'd Nick go? So anyway, again, pizza's on its way, so hold tight. We'll work up an appetite, and then we'll eat. So part of the thing that Nick asked me to do is kind of run tag team with a couple of people on the program management side of this air quality task that we're working on. A couple of things I just wanted to point out from tracking and issues, that kind of stuff. Has everyone been in Jira here? The Jira instance that we're using?
I know it exists.
So you've seen it. Some people are in it. You people have not. Okay, so we're going to kind of go through that a little bit. Pat's going to kind of take us into how we get there. I registered this morning. He understands you don't have to, so we need to figure that out so we can let people know whether you have to create it. I mean, I think we would like to have everyone to create an account so we know.
Yes.
But I don't think that, well, I'm not going to say I don't think you have to. Let's make us an account so we can make sure everybody's. So those of you who've been out there, are there any issues that you're tracking or working on that you'd like to talk about? Or is it kind of a fact finding? I want to see if I can get out there and that stuff. So as you can see, oh, where'd you go? You going back over there?
This link right here. There you go.
Okay, so I'll get you into our Jira account. You can see these are the issues. One thing we've got to take note of is Pat is the owner on all these, and we have to keep that way. So what we ask you to do is just follow those issues that you're engaged with and working on. That way we can get multiple people engaged, get the collective mindset going on an issue, hope we can get it resolved. But if we have an assignee and something may happen to them and be caught up in a work issue, we have to work 80 hours one week, then we're dead. We may be stuck. So we're asking that we just follow issues versus own them and let Pat be the owner so we can kind of keep things up in the air. And even though we have a few followers, or that's what we hope, is have several followers on an issue to get that collective mind stuff going and working on those things so we can get them resolved, keep the process going. Any questions on that?
By following, you mean watching.
I mean watching, sorry.
Yeah, if you click watcher here, your button will say watch this issue. If you say watch this issue, you'll get an email anytime the issue is changed, modified, commented on, anything like that. So if anything happens with the issue, you'll see it. You'll get an email about it.
Good point. And then
that's what you want to watch.
Yeah, and then as you make things happen on it, just make sure you comment on it so other people who are watching can see the progress, things that are happening, or be able to share that kind of content information back and forth with that housed group, if you will, right? So any questions on that space?
There is one more link, say that data list, and there is one thing here.
Yeah.
So what is the difference?
I'll show you in about 5 seconds. As soon as, or is there any other questions? And then I'll show you what.
Yeah, I think with that, Pat, why don't you get into some more
So-
detailed depth that covers that. Let me back up out of your
So this list of current sets Google Doc. That opens up this Google Doc right here. Okay, now this Google Doc lists all the things you've submitted in a form to us. I have now updated Jira with all of these. You can see their tickets there on the right-hand side. That's their Jira ticket number. I'm going to keep doing that as they come in. I will keep adding them to Jira back and forth. This is here for nothing more than basically reference. I would use Jira to track the tickets. I would not use that.
Go either way. So you recommend that we go either.
I recommend that you go into Jira, yes, because there are a few tickets now, just this morning that I added, that are not in that Google Doc. And the reason that is because they were submitted directly to the state by me instead of through the Google Doc process. So my suggestion now is that you use Jira for all issues, no matter what. If you want to see something that maybe you just submitted yesterday and I haven't put in the Jira yet, this would be a place to look and see. If it does not have a Jira ticket on the side, it's not in Jira. That's it. Okay?
Good to know.
But definitely use Jira for everything. So, some of the new things. All of these list data set, data tool. I have new ones also that say information. It's not in here because I have this label filtered. But right here, information. Someone submitted a wonderful PDF that has some information about what's being done. but it doesn't necessarily have a data set on it. So it is information. So you want to look at those tickets as well. You can see all tickets related to this, no matter what it is, when you go to all issues. All right, so they're all listed there. Now there's some new ones as well that everybody's going to want to start looking at, and this is the data I've been talking about a lot, the UDOT traffic data, the PENS data is what it's called. This takes you to a website that allows you to create a login, and then you can actually export the data out to a table, text file, all sorts of fun stuff. There's my link to it. You can see I've been going through quite a few of them. PENS. So I can come into here, I can find some sort of data that I'm looking for, and then it allows me to export it down. So aggregate summary. Not that one. Oh, I got to log back in. Never mind. You can go and look at it and take a look at it. I want to give David and other people more time. But the point is you have to create an account in here. And JIRA lists it all out right there for you. Exactly what they've told us from the States. This is what you need information. If I say from the States, that's a quote directly from them. Okay? We need to try to keep communication to a minimum there from just me, so I will communicate for you to the States. If there's any questions, feel free to email me. I'll answer that anytime. Another big one that was just added that is really cool, the signal performance metrics. They track what the signals do at various intersections. I think they said there's 700 intersections or 7,000 intersections, one of the two. But basically, you can export this data as well, or you can get it right down here. And you can see how long people are sitting at lights at various times. So again, wonderful correlation you can do with other air quality metrics that are out there. So yeah, now in JIRA, we have, I think for data sets, I think we have 24 different items inside here, if I remember correctly. Let me go back to my filter. Data set. 26. So there's 26 different data sets to play with now inside here. I added probably about 15 this morning. So there's a lot more stuff to play with, a lot more stuff to look at, websites to hit that people have submitted and from the state. And we're working on several more this week. So a lot more fun stuff to go and look at and play with and start working on.
Well, my suggestion would be is find some of these data sets that pique your interest. Let's start digging into them. Like I say, watch those, add some comments, go hack the data, see what kind of information you can kind of pull, and then hopefully through just kind of polarity, we can get people that can kind of say, well, somebody else is involved, so I'd like to say if we get 3 or 4 or 5 people involved in those things, I think it'd be great. Those little sub-teams and make sure they start looking into these issues. So I would encourage you to do that, and let's get this thing going. So any other questions or comments on JIRA, the information that's out there, how to get on it, etc.?
Another big thing, when you go to these sites, when you go to the data sets, as Ben had showed us before, there's ways to get the data off the sites. Make sure you write some sort of simple one idea or something like that. You may not have the chance right now to run every day and run a script against it. You won't want to DOS anybody, but we're going to be getting resources to do that type of work in the very near future, probably next week or the following week. So even if you write just one script that goes and pulls one day, we may have a system in a week or two that can then run that for you over 365 days. Not a problem. So don't worry too much about the huge nature of I've got to write this entire map reduce process that does everything. Maybe you just need to write the script to start getting this work.
Good point. Good
yeah. So don't feel too daunted about I have to go and buy an Amazon cluster to pull all this data. We're working on that right now.
So 2 quick things. One, you may have already mentioned this, but has everybody been finding, one of the things you should be doing as you're looking at all this is thinking through what other data sets might be helpful. Have people here had a couple of data sets that you've gone, oh, I wish I had this kind of data? Like Ben brought up avalanche data a little bit ago. We were able to go out and find that.
I forgot to add that one this morning. So today, this afternoon.
I think the avalanche is in July, right? Come on.
Well, it was here, guys. Yeah. I don't think I've still had the FAA data.
I don't think you have. Yeah.
We now have aeronautics data for local airports as well as the FAA data as well. So I'm going to get both of those in there. And then the other thing I wanted to mention, and maybe you'll go over this, David, I don't know, but in Ben's presentation, he showed how to pull information off of graphics and everything. But like Kieran mentioned, that there are some of these that are just PDFs or other kind of things. Can somebody talk? Maybe you can talk about how to get that off there without having to okay to pull the data off of PDFs. Yeah.
And always keep in mind that if one of these says it's a PDF, and there's one in here that's just a PDF, it has tables inside it. If someone says, I don't know how to get this on there, we're going to ask these other people that do. That's the whole point, is to get other people to help you learn how to do that. So if you find a data set and you're like, I have no idea how to get this, post it in the Google group, post it on the comment here. We'll start farming that around and find other people that do know how to do that. It can give you an idea or a path to go in. It may not be, here's the script, here's how you go and do it, but it may be, here's where you should go and here's where you should look. You know, it might be an introduction. Because the whole point here is to learn something new, right? You don't want to just keep doing the exact same thing over and over again. We want to learn something new. So
We're all in this boat.
Yeah, exactly. So the pizza is supposed to be here. We've been calling to find out where the heck they are, but as soon as it gets down here,
I think the third one is big gathering. It's
that's probably exactly already. Yeah.
yeah, let's let David get started. When the pizza comes, you can take a quick break or something. Everybody can get some, and then we'll keep going.
Right.
So let me pull that up for you, David.
All right, so I made a really sexy presentation, and my dog ate it, so then I had to make this one. Yeah, go ahead and put it into whatever. There you go.
See if you can move back and forth.
Let's see. No. The green thing works.
Try it. Maybe it just doesn't like that.
Is there a presentation thing?
Hold on, I gotta switch this. Yeah, no, that's.
No, but like if you go up here to like view, or maybe.
Screen mode is what I would think.
Yeah, that's what I think.
No, try that.
There it goes.
All right. You're good.
All right, so the presentation is supposed to be on scraping, and here's my problem with scraping is the first thing that I'm noticing is I would say we're kind of scraping the bottom of the barrel for questions to ask. So I just wanted to start with like when I go about looking to solve a problem, I usually want some real tight constraints on what that problem is. And the more, I don't know, the more charged the answers I can get, the better off I am in terms of results. And so an example of that would be, who is to blame for Utah's bad air quality? That seems like a great kind of question to be able to answer, like, because you want to put the blame on somebody so that you can absolve yourself of any responsibility. And the other nice thing is that, you know, on a site like Fox 13, we actually get to see some big data at work. You know, I logged in with my Google account, and so it thinks I'm a woman and keeping women healthy. Or maybe it knows I'm married, who knows? Or maybe it's just dumb and it's just cycling through. But hopefully Fox is paying a little bit of money for their ad retargeting. And so when we go into like who is to blame for air quality, let's get a sense like who would you blame? Show of hands. Wood burning stoves, like biggest contributor. Okay, so that's what is that? That's 5% of people here. Okay, so cars and transportation. Okay, so we got some double dippers there. All right, so that's about 30%. Industry, the biggest polluter. Oh, industry. So we've got that's 1%, I guess, of the people here. I think the industry is the biggest polluter, and then like aircraft. Okay, and then just God might be. Okay, so we got another 1%er. It's like, we're just going to blame God. That's what I tell my kids at home. I'm like, you can blame me, because whoever gets blamed gets responsible. Ultimately, just blame the universe and then move on with your life, right? So here we go. Pollution sources. Right? So at least Utah Division of Air Quality, pretty reputable source. Who knows? Maybe they're lying too. But I'm thinking it's pretty good, right? We've got almost 40% cars and trucks, so we're saying that you guys are pretty good on that one. Large industry, we were totally off the mark on large industry. We only have 1%. They're actually almost equal. Commercial, enterprise, and then the wood-burning stove is actually a smaller portion of households, so you guys are all wrong on that. But what I want to point out is they get a gold star because this actually adds to 100%.
Yeah, these are on.
And Fox News sometimes doesn't always add to 100%. So, I mean, we can give them style points, right? It's like, oh, good, somewhat likely, good old Palin, 70% of almost 200%, so that's nice. Okay, so if we break this down, when we're trying to scrape, to answer, the where, what, why, when, right, who. And so in the article, I found some things that, it's like, okay, so Utah says 38% of states air pollution from cars and trucks. So the question is, what data can we go after, and what form is it going to be in? And can we establish that? Can we individually, can we actually find out like what that number is? 30%, 38% of what? Do we go after CO2? I don't know. Can we find out? Can we establish that that actually is a thing and it turns into something else? So we might have to scrape some data off of, the traffic data. And scraping isn't necessarily, as I'll show, like it's not, you don't have to do, though it is fun, right? What Ben said, you can go into and find out where their API is and actually just bombard their API and get back the raw data that's being served at the website. That is fun, I'll admit. It's a whole lot of fun, especially when you take down someone's site. Because then it shows they're just not very sophisticated about things, because most people are smarter than that. They'll just give you back a fake broken site. Large industry, 20%, so combined 26% comes from commercial, like fast food restaurants, business and small, and business. I don't even know what fast food restaurant pollution would look like.
Burger King.
Well, I know it pollutes me. Like, so the Burger King, okay, so Burger King has some smoke coming out. Commercial, yeah, that I can understand, like the transportation side, but like I'm just trying to figure out, like, other than filling the air with, sumptuous smells, like, so Burger King I can see, right, because they got a grill and they got fire and stuff, but the first thing I thought was, well, if wood-burning stoves aren't that big a deal, then maybe Burger King's not that big a deal. So what is it, right? And how do you test this hypothesis that they're actually a polluter? Right? How would you test that hypothesis? Got any ideas? It changes over time, but I mean, how are you going to be able to? Look, for instance, we're in the future now, and we've created something. How can you predict air quality based on restaurants?
So maybe look at sensors and find if there are any sensors that have a restaurant here and what hours those operate and to have more fires or anything else during those time periods.
Great. So you could actually, so common sense says, boil it down not to this enormous problem, but maybe 2 data points and see how they correlate. Right? Let's correlate some emission and restaurant concentration, I guess, right? And maybe a third would be hours of the day. That's great. Those are 3 data points. So that's a nice, really narrow, really long, right, every hour of the year. But that's a nice, narrow data set. I'll bet you that data set probably fits in memory. So you could probably analyze it in Excel. The reason I'm saying this is because I think part of the barrier to entry in a lot of what we're doing is thinking that you have to use very sophisticated tools to do this. And that's not true. If you're Ben Taylor, it is. You're going to go ahead and swat at mosquitoes with a bazooka because he knows that at some point the problem is going to get so unwieldy that he's going to need a bazooka. And he's right. Like, a lot of Ben's problems are so unwieldy that, it's just going to be a huge shift of tool sets to go from solving a very small problem to the kind of problem that's going to back out for what he's working on. But for this, to get started, you don't need a whole lot of sophistication. So don't think that you have to use R and it's some new novel language or even Python. though I would suggest that both would be useful. If you come from an SPSS background, I'm sorry, but you can still use that, and you could use anything you want. You could even use command line tools, right? So
to be a contrarian, well, I agree with everything you're saying, but for the other side of like maybe Ben looking at the food side. So let's say instead you maybe didn't know that you were looking for fast food restaurants, but you now wanted to solve for X, and X was a pollutant that maybe is outside of.
what I'm going to say though is when we talk about having that intuition, right? Having that intuition, that is what I categorize as domain expertise. Domain expertise comes from running a very simple problem and going, there's a lot of noise in there, or Whenever you say and the data doesn't give you back the expected result, you're getting a little sharper about the problem. But you have to pay that price of knowing a little bit. And so then you could decompose restaurants, or you could decompose transportation as maybe it's airplanes, maybe it's trucks, maybe it's light cars. Solving that starts to get a little deeper, right? You can start to look at time of the day, and you can start to look at population centers and who would be traveling between this point and that point, and that might be able to help you understand exactly who to blame, because at the end of the day, that's what you want, right? So, well, I mean, I guess what I'm saying is when you're talking about blame, we're talking about is it causation, is it correlation, and if you can find somebody or you can attribute the blame to a variety of different things, then the follow-on question is really interesting, which is, okay, if so-and-so's to blame, can I personally do anything about that? And what would I do? And if I'm to blame, or if someone to blame, what can I do about it? So then you ask big industry, and they're like, well, come on, guys. We only contribute 5.8% of all annual emissions in the local airshed. And what I love is I would love to be responsible for 5.6% of anything at a statewide level. I wouldn't care, like corruption, fraud, anything. If it could be measured at the level of an entire state, I would be patting myself back. Good job, guys. We made a dent in the universe. So they made a dent in the universe. They're about 6% of all of the local airshed conditions. That's amazing. I wonder what that weighs, right? I do. I wonder what that weighs, and I wonder how often, and can we find sensors? Because there's not. You look at that sensor data, and there's not that much around there. So who knows, right? But, and then we can say, okay, so they say that they shut down the power plant during the winter, and that they're also above the inversion line. That seems like an interesting thing to test. Because it turns out that big industry or commercial, I'm thinking this fits under big industry, is almost 40% of our air pollution problem. But at what time of the year? Is that 40% of our air pollution problem during the inversion when we're all stuck in this cave of crap? Or is it when the wind's blowing in, and if it's blowing upwind me, then I don't care personally, right? I'm okay. So that would be an interesting thing to go after. And scraping that data, I don't know. I don't know what it looks like. It probably looks like just taking a very large data set and pulling something out of it. If that very large data set happens to be even pretty friendly for you to use, what you're going to find is to analyze it with a little more than just like a pivot table, then you're going to have to turn it into data that you can actually analyze. And that's usually not, like even dates, it's not a great thing to analyze, right? You want to break it down in a year, and the day, and the month, and the time, and maybe the seconds, right? Maybe the time zone's going to be a minute. So breaking that down, number one tool in all of this is regular expressions. It's just what we use. It's what's behind when you go and search and replace in Word or anything like that. You just have regular expressions. I don't write much Ruby code anymore, but I still love this stupid tool online, rubular.com. It's so great because under the fold, right under here, it tells you almost all of the standard ways to use regular expressions, which are sometimes hard to remember. So you just type in, what does this do? And you type in something like /W. And it goes, oh, it highlights all of the word strings. And then you can group it, right? You can put parentheses around things, and you can return just that group. And so what you could do is take a very large document and just strip out one kind of data point out of it. And then you don't have to deal with all the other stuff. That's really nice. Or you could replace certain things with things. You're like, oh, well, that's not really helpful to put that thing next to that other thing. So you just replace it. And what you're trying to do with scraping is you're actually trying to turn a bunch of variety of different crappy data sources that are pretty unwieldy. And PDF was mentioned. PDF is just a text document if you open up a text editor, unless it's been compressed, right? But more often than not, it's just a text document. And there's great tools. PDF Miner is a good one in Python that I'll use. And I'll update this after here and post it. And you can see I've got a Git repo that actually takes the PDF documents from UDOT and pulls it into just text, and then you just parse through it using a Python script to pull out just the data that you want. Because you don't want all the data. And it would be nice if it came in a nice tabular form, and you could just put it right into Excel or anything else. But what I found over and over again is somewhere along the line in government, everybody decided that PDF is going to be the future-proof document. I remember having this conversation when I submitted my thesis. They're like, and they were telling me it's really exciting that you can now submit just the document as a PDF, and they're going to archive it for me for eons. Because in 2340, they're still going to be able to read PDF documents, but text is going to be too hard to read, but PDFs are going to be around forever. So for whatever reason, PDF's a big thing. If you go to like the government websites, you'll find that like even the guy who has access to the data doesn't even know how to query it. They just use PDF documents. So it's unfortunate, but there you go. So you got to do that, and you can scrape the web, and you can scrape big data and PDFs and text and the whole 9 yards. Well, how do you do big data? You start by making it much, 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 much smaller. You just chop off 10,000 lines, see what it does. So you can play with it. So you could actually load it into a text editor and look at it. Because if you try and load a document that has 78 million lines, it doesn't matter what you're using, it becomes problematic. And there might be trends in a 78 million line file that are useful, but not until you look at it. Go ahead.
Okay, so let us say you have 78 million or whatever million lines or whatever. How do you decide which 10,000 or which 1 million to have?
You don't. That's the thing is, it's actually so difficult to work with a document of that size or a file of that size that you just take, this is a Linux command line, you just take head-n 10,000, and it takes the first 10,000 lines.
More broadly, though, sometimes you want to randomly sample from every year.
That's what I was trying to get
Because it's a look at it initially. You're not
Yeah, but you have to decide that you can actually deal with the document itself, look at what's in there and find out. And then if you want to do some kind of sampling on the entire document, you need to be pretty comfortable that you know what is in there and what columns you're going to sample and what, because that's going to be a long-running, it may take an hour, it may take 2 hours to adequately sample with any tool 78 million lines. So what I'm saying is, for most of the people in this group, the very first thing they need to do is actually take a file, download it, and look at it. And if it's a very large file or it's an HD5, right, then they're going to have to load in and look at what's in that data set. Because it's actually too large a problem to say, I'm going to spend some time thinking about what might be in the file, and then I'm going to ask it questions to see if that's actually what's in the file. When you could just load in, and maybe you're ambitious, load in 1 million lines. It's still going to fit in memory. It's still useful. It's still easy to work with. And then you can start to ask questions, and you could use other tools. I've used awk, right? Awk's a great tool to just pull out specific columns, make your file, dealing with a genomic data set that's 26 gigabytes in size. Well, it turns out there's only a handful of things that are really useful in there. So I made it much, 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 much smaller. And now I can play with it and work with it and start to see if proof of concepts work, and then try and deal with the 26 gigabyte file.
So what do you think of taking like a thin slice of data? You're choosing, maybe 1 or 2 values per dimension. then reducing it that way. So you say, I'm only gonna look at Salt Lake County in Utah, perhaps a certain section, and then find out how many records that is, and use that as a sample. Because it seems like it would be better correlated data than just randomly sampling across these records.
I couldn't agree more. That's right. And then if you find that, hey, you know what, it backs out for Salt Lake County, or even a smaller geo than that, if your idea that these things are tightly correlated or somehow related, if that actually turns out to be true, then you can scale up your solution. And then you start to think, well, how am I going to figure that out for everything? Now you might be in a situation where you need to run MapReduce on a cluster because you can't do it on your desktop or your laptop because it's just too much data, right? But you're not going to know to run a MapReduce on something until you know what's in there and how you're going to go about doing it. So to give an example, I had to deal with a very, very large data set of most of the population in the US, and this was about 4 years ago, and so I used awk because I didn't know much about Hadoop. It turns out that just farming out awk on a bunch of nodes was really, really effective. And then I found out about Hadoop that same week and ran a MapReduce, and awk tied with Hadoop, right? So the problem probably wasn't very complicated, but what I'm saying is Hadoop is not, it's not that sophisticated a tool to use. It doesn't require that much complexity in how to understand how to use it. What's complex is what's underlying, the stuff that none of us care about is how it does what it does. We don't need to know how it does what it does, as long as we can ask it to solve problems for us. So, yeah, so tools that I use for scraping data, I use Vim a lot. Pull off the top of a data set. Because, you know, with a little bit of Googling, you can have Vim come out nice and pretty, and when you type / and you find something, it'll highlight all of the things that are in there. And then I'm, oh, that's interesting, right? So Vim plus regex with big nasty Excel data files that sometimes, again, if it's not PDF, then it's going to come to you as an Excel file from the government, which is also nice because it's a binary and it's an absolute beast to work with if it's pretty large. But, you know, XLRD will help you stream an Excel file. So that's really, really useful. And again, you can chop up the first few lines and look at it. If you're going to be going and really scrounging the web, Beautiful Soup is a great one, right? So it'll handle traversing the XML structure of an HTML file, and then you use regex to read out the pieces within a div or something that you actually want. But I wouldn't go there first. I'd see what you can do, how dangerous you can get with other data sets. And that's it for scraping. Because I don't know what you guys want to scrape. And I don't know what you'd go to scrape after, but I would really suggest that you try and find a very simple correlation that you think matters. And try and prove one of these things here, right? Try at least start there, try and prove that, and decompose one of these things. And then what you might be able to find is, what I'm interested in looking at is, how does this as a whole affect the population? So Salt Lake County School District is going to give us all their attendance records for the past couple of years. I think that'd be kind of interesting to look at pollution versus school attendance. Maybe there's a correlation there. It's not too hard. It's not that big a data set. I'll probably do it on my laptop. And whatever I find out, I'll tell you guys. But you guys should go after this because it's because each one of these little tiny problems has with it. Each one of these larger problems has a very small, tiny problem inside of it, and all of us are actually adequate for doing that in whatever tool we already know. And then if it works out for you, then try and make it more complex and tell us about it because I'm sure someone will help you make it more complex.
Are we only looking at data for
That's up to you. Yeah, I would say, you know, tell us something about Utah and then tell us how it compares. And then tell us maybe how it compares to China. But let's see if we can answer a small problem first. Because I haven't seen much activity about very small answers. So that tells me that either you guys are all in caves and you've actually got really awesome solutions and you're working at, and no one's telling anybody about the fact that they've figured out how to solve air quality by reducing Burger King emissions. and that's a politically viable solution. Or what is more likely is we're all busy doing other things, and this sounds like an enormous problem that we can't solve, so we're just not even going to try. So make it small and see what happens. And a very small solution is actually going to be kind of exciting. Any other questions on scraping? You're
One thing I was
happy
gonna mention there.
you're happy to hit me up with any questions about specific regex or something like that. I'm happy to.
I was just gonna mention, repeat the question so that the people in the.
Oh yeah. I think it was implied in that answer. But Mike.
Comment in the form of a question.
Nice. I like those. So this is a comment in the form of a question.
But in general, what tools do you use when you're writing a scraper that is collecting data proactively? Because there's a lot of data that you get is historical, and sometimes there's inherent value in the data now. Because as an analyst, you're looking around. If you're feeling now, you want to capture data in a certain place that you're looking at. It helps you for integration purposes, but sometimes it's just good information now, in the here and now. Basically, creating a scraper that just get back data from the public. So what are the basic tools you use to create that?
Great question. So the question, so the question comment was, if you find what do you do to collect data now? How do you go after data right now? And the context of that is that you've already done a historical look at some data set that's already existing somewhere. And you've decided this is really meaningful and could be meaningful in a more timely fashion. So that kind of depends on where the data is coming from. If it's on the web, it's not that hard to, a very basic one that all of us has within our reach is that even if you, on a PC, I can't remember what it's called, but on Linux, the most basic form is you write a cron task to execute a script that you've written that collected it for you the first time. You just run it every minute or hour or second or day. If it's a data source that is already kind of friendly, real-time data source that's really friendly is Twitter. They have an API for you, and you can just write a script and ask it to send back to you, and you just run that script, and it'll give you as timely as you can afford. And then if you're going to get really, really complicated, and it's data that you want to stream, there are more complicated tools, but try those first. Right? Try something that just automates the process of asking for the data over and over again. Any other questions, comments? Pizza smells good.
When we, I run into situations that we have data that is stored, for instance, in the mainframe, and that one is kind of empty, that code, and you want to transfer to your PC, or so transferring that you have to compare that to ASCII. So that process, you have any tools or how would you handle?
So you said you have data on a mainframe?
Yeah.
And you want to get it onto your desktop? Right.
Well, to manipulate that in ASCII form. So that one is, in mainframe is storing every code, and then you have to transfer that one to ASCII and compare it to ASCII.
Okay, I think I understand. So your question is, how do you ETL data, right? Or from a large data store? Is that?
I've actually had that problem. I haven't solved it, but I know who does solve it is the guys in Science Bank.
It's a hard problem, actually. So this copybook, Lexar, is an open source package by IBM. This copybook is a binary mainframe thing. It will extract and give you like an XML document of that you see the CTF-8. So Lexar, something with this
Cool.
copybook.
Lakestar or Lexstar, like LaTeX or something? Yeah, Lex. Okay.
I just used this recently though for myself, and it works pretty well. It's pretty.
Does that sound like it's answering, Brennan? Or
Yeah, I think so. It's a case by case basis.
Yeah.
It doesn't lend itself very well. So you have to convert it to some ASCII and.
Yeah. So the question in a nutshell is, what do you do with really gnarly data forms that exist in weird places? Because the solution is still relevant. How do you get that to be just a nice, friendly text document that you can deal with? And depending on how gnarly the data form, it's going to require a pretty gnarly solution. But yeah, we reverse engineered Word so that we could get at its binary format. If the data is valuable enough and proprietary enough, but open enough, you put enough pressure, and eventually even Microsoft will go to an XML format and realize that their integration was actually what they're selling, not the word processor. So, yeah.
I think you asked the group though too, because there's like a ton of.
Oh yeah, just save time. Like don't. Yeah, and I would definitely caution you to get any more than about an hour into a problem with a gnarly data form without asking. Just like, yeah, post to the web, and somebody will help you, right? And they'll tell you Lexstar might work for you, and then we'll try that, and that'll save you a lot of heartache. Okay, any other questions? Great, thanks for your time.
And as always, thanks for coming, everybody. I guess we got pizza after. You're welcome to socialize and talk, and like I said, work on any other data sets. There will be some new ones added. I've got a couple from Nick. And then hopefully early next week I'll have some health data ones. We're working on that with the state as much as possible. And then, like I said, we've got some big resources coming up very soon. And I'm glad that David mentioned, grab small pieces, write a script that just gets the small piece of it, because you can hand that off to a much bigger cluster that we're working on getting. And once that cluster is available, it could go really quickly for you. So don't bang your head against the wall trying to pull millions and millions of rows of data. Get one piece working, and then let's work on a solution together. Make it a lot better. Okay. All right. Thanks, everybody. Grab some pizza and hang around for a little bit. Thank you, everybody that joined on the call.
Person who created this on by accident, intentionally, make this the data that was.
Oh, I